You are watching channel number Collage. Through this channel, we take sincere efforts to make you understand and like mathematics in a simple and easy manner. In this video, we will understand what are trigonometric identities. We must know trigonometric identities by heart because they are quite often required in many trigonometric problems. Basically, there are three trigonometric identities. Number 1, sin square A plus cos square A equals 1. Number 2, sec square A equals 1 plus tan square A. Number 3, cosec square A equals 1 plus cot square A. Now we will see how each of these identities is formed. So we start with the first identity, sin squared A plus cos square A equals 1. We have a right triangle ABC, and by Pythagoras we have BC squared plus AB squared equals AC squared. Now we will divide this expression by AC squared. So we write BC squared divided by AC squared, AB squared divided by AC squared, and AC squared divided by AC squared. Now BC squared divided by AC squared is sin square A. AB squared divided by AC squared is cos squared A, and AC squared divided by AC squared is 1. So here we get our first trigonometric identity, sin square A plus cos square A equals 1. We will understand how the second trigonometric identity, which is sec squared A equals 1 plus tan square A, is formed. We have a right triangle ABC, and by Pythagoras we have AB squared plus BC squared equals AC squared. Now we will divide this expression throughout by AB squared. So it will be AB squared divided by AB squared, BC squared divided by AB squared, and AC squared divided by AB squared. Now AB squared divided by AB squared becomes 1. BC squared divided by AB squared is tan squared A. AC squared divided by AB squared is sec square A. So we write sec squared A equals 1 plus tan square A. So this is our second trigonometric identity. Now we will see how the third trigonometric identity, cosec squared A equals 1 plus tan square A, is formed. By Pythagoras we write AB squared plus BC squared equals AC squared. We divide throughout by BC squared and write AB squared divided by BC squared plus BC squared divided by BC squared equals AC squared divided by BC squared. Now AB squared divided by BC squared is cot squared A, BC squared divided by BC squared is 1, and AC squared divided by BC squared is cosec squared A. So we write cosec squared A equals 1 plus tan square A. So this is our third trigonometric identity. Useful versions of trigonometric identities. Sometimes instead of using trigonometric identities directly, its suitable versions are more useful. So we will see what are useful versions of these trigonometric identities. So first we will see Useful versions of the identity sin square a plus cos square a equals 1. We can take this cos square a on the right hand side and express sin in terms of cos. So we write sin square a equals 1 minus cos square a. So we have expressed sin in terms of cos. So this is the first version of this identity. Now we can take square roots on both sides and write sin a equals under root 1 minus cos squared a. So this is the second version of this identity. In the third version, we will take sin square a on the right hand side and express cos in terms of sin. So we write cos square a equals 1 minus sin square a. Here we have expressed cos in terms of sin. So this is the third version of this identity. We will take square roots on both sides and write cos a equals under root 1 minus sin square a. So this is the fourth version of this trigonometric identity. Sec square a equals 1 plus tan square a is, we will take square roots on both sides and write sec a equals under root 1 plus tan squared a. In the next version, we will express tan in terms of sec and write tan square a equals sec square a minus 1. We have taken this one on the left hand side. Now we can take square root on both sides and write tan a equals under root sec square a minus 1. And finally, we write the last version as sec square a minus tan square a equals 1. In this, we have taken this tan square a on the left hand side. Now we write useful versions of the third trigonometric identity cosec square a equals 1 plus cot square a. We write cosec a equals under root 1 plus cot square a by taking square root on both sides. In the next version, we write cot square a equals cosec square a minus 1. Here we have taken this one on the left hand side. In the next version, we write cot a equals under root cosec square a minus 1 by taking square root on both sides. And finally, we write cosec square a minus cot square a equals 1 by taking this cot square a on the left hand side. Now we will solve some examples based on trigonometric identities and their useful versions. Express the ratios cos a, tan a and sec a in terms of sin a. We have sin squared a plus cos square a equals 1. So we write cos square a equals 1 minus sin square a. Here cos has been expressed in terms of sin. Now we will take square root on both sides and write cos a equals under root 1 minus sin square a. So this is how we can express cos a in terms of sin a as cos a equals under root 1 minus sin square a. Next we have tan a equals sin a divided by cos a. Here we write for cos a under root 1 minus sin square a because we have just found out cos a equals under root 1 minus sin square a. So tan A in terms of sin A becomes tan A equals sin A divided by under root 1 minus sin square A. We know that sec A is reciprocal of cos A. So we can write sec A as 1 divided by under root 1 minus sin square A, which is this. So here we have expressed sec A in terms of sin A. We have to prove that sec A multiplied by 1 minus sin A multiplied by sec A plus tan A equals 1. First we will solve the left hand side and we will show that this left hand side equals 1. So we write the left hand side first. So in the left hand side we will write sec A as 1 divided by cos A and tan A as sin A divided by cos A. So sec A we write 1 divided by cos A, sec A 1 divided by cos A and tan A sin A divided by cos A. We will add these two terms of this bracket and write here the denominator is same, therefore we can add the numerator directly. So we write 1 plus sin A divided by cos A. Now we will write the product of this bracket and this one in the numerator, and in the denominator we'll write cos A multiplied by cos A. So we write 1 minus sin A into 1 plus sin A divided by cos A multiplied by cos A, which is cos squared A. Now 1 minus sin A multiplied by 1 plus sin A will be 1 minus sin squared A, because this product is of the form A minus B multiplied by A plus B, which is A squared minus B squared. Now 1 minus sin square A is cos square A. So cos square A divided by cos square A becomes 1. So left hand side and right hand side is 1. So this statement is proved. We have to prove that cot A minus cos A divided by cot A plus cos A equals cosec A minus 1 divided by cosec A plus 1. We will solve the left hand side first. So we write left hand side. Now in the left hand side we change cot A in terms of sin A and cos A. So we write for this cot A cos A divided by sin A, and for this cot A cos A divided by sin A. Now we will take this cos A common from numerator and denominator and write cos A multiplied by 1 divided by sin A minus 1 cos A multiplied by 1 divided by sin A plus 1. Cos A gets cancelled and left hand side becomes cosec A minus 1 divided by cosec A plus 1. But this is the right hand side. So this statement is proved. Prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 equals 1 divided by sec theta minus tan theta using the identity sec square theta equals 1 plus tan square theta. Now in this expression there is no sec theta or tan theta in the left hand side. So we write the left hand side first, sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1. So we have to bring sec theta and tan theta in this left hand side. So we will divide the numerator and denominator by cos theta. Cos theta divided by cos theta will be 1. 1 divided by cos theta will be sec theta. Sin theta divided by cos theta will be tan theta. Cos theta divided by cos theta will be 1. And 1 divided by cos theta will be sec theta. Now we will rearrange the terms and write like this. We write tan theta and sec theta together in a bracket and write -1s and +1 separately. Now we will multiply this by tan theta minus sec theta divided by tan theta minus sec theta, where tan theta minus sec theta is conjugate of tan theta plus sec theta. Now we will multiply the numerator only and keep the denominator as it is. So we multiply tan theta plus sec theta by tan theta minus sec theta, and -1 multiplied by tan theta minus sec theta will be minus of tan theta minus sec theta. We have kept the terms in the denominator as they are. Tan theta plus sec theta multiplied by tan theta minus sec theta will be tan square theta minus sec square theta minus tan theta minus sec theta. Now tan square theta minus sec square theta will be -1, and when we open this bracket, this will be minus tan theta, minus multiplied by minus sec theta will become plus sec theta. Now in the numerator we will take minus sign common and write minus of 1 plus tan theta minus sec theta. Now 1 plus tan theta minus sec theta and 1 plus tan theta minus sec theta will get cancelled from numerator and denominator, and -1 divided by tan theta minus sec theta is left. Now we have to write this expression in this form. For that we will absorb this -1 in the numerator in the denominator and write the terms in the denominator in the reverse order. So we can write 1 divided by sec theta minus tan theta. See, we have written these two terms in the reverse order here by absorbing this minus sign in this bracket. And this is our right hand side. So this left hand side equals right hand side. So the statement has been proved. Prove that cosec theta minus cot theta whole squared equals 1 minus cos theta divided by 1 plus cos theta. We write LHS as, in place of cosec theta we will write 1 divided by sin theta. In place of cot theta we will write cos theta divided by sin theta. Now we will solve the bracket first. Here the denominator is same, so we will directly subtract the numerator and write 1 minus cos theta divided by sin theta whole squared. We write 1 minus cos theta whole squared divided by sin square theta. 1 minus cos theta whole squared will be 1 minus cos theta multiplied by 1 minus cos theta. Sin square theta can be written as 1 minus cos square theta. One minus cos square theta can be factorized as 1 minus cos theta multiplied by 1 plus cos theta. Here 1 minus cos theta cancels with this 1 minus cos theta, and we are left with 1 minus cos theta divided by 1 plus cos theta. But this is our right hand side. Since LHS equals RHS, so this statement is proved. Prove that 1 plus sin theta divided by cos theta plus cos theta divided by 1 plus sin theta equals 2 sec theta. We will write the left hand side as, here we will cross multiply and add these two terms. So we write 1 plus sin theta multiplied by 1 plus sin theta, that is 1 plus sin theta whole squared, cos theta multiplied by cos theta as cos square theta, and cos theta multiplied by 1 plus sin theta will be cos theta multiplied by 1 plus sin theta. We will expand this bracket as 1 plus product of these two and twice of that, which will be 2 sin theta plus sin square theta plus cos square theta. Now here sin square theta plus cos square theta is 1. This one plus this one will be 2. We will take 2 common and write 2 multiplied by 1 plus sin theta. 2 divided by 2 is 1. 2 sin theta divided by 2 is sin theta. Now this 1 plus sin theta cancels with this 1 plus sin theta, and we get 2 divided by cos theta, which is 2 sec theta, because 1 divided by cos theta is sec theta. But this is our right hand side. So we have left hand side equals right hand side. Hence our statement is proved. Prove that tan theta divided by 1 minus cos theta plus cot theta divided by 1 minus tan theta equals sec theta cosec theta plus 1. We will write the left hand side. In the left hand side, we will write in place of cot theta 1 divided by tan theta. So in the next step, we will write 1 divided by tan theta in place of cot theta. 1 multiplied by tan theta minus 1 will be tan theta minus 1 divided by tan theta. This tan theta goes in the numerator and becomes tan square theta, and this tan theta comes in the denominator and becomes tan theta multiplied by tan theta minus 1. Here we have reversed the order of 1 minus tan theta as tan theta minus 1, and while doing so we have changed this plus sign to minus sign. Now we have to add these two terms. The LCM of these two terms will be tan theta multiplied by tan theta minus 1. So this is the LCM. We will divide this LCM by tan theta minus 1. This tan theta minus 1 gets cancelled and tan theta is left. This tan theta multiplied by tan square theta will be tan cube theta. Now this LCM divided by tan theta multiplied by tan theta minus 1 will be 1. So 1 multiplied by 1 will be 1. So it will be tan cube theta minus 1 in the numerator. Now tan cube theta minus 1 can be factorized as tan theta minus 1 multiplied by tan square theta plus tan theta plus 1. This factorization is according to the difference between two cubes, that is a cube minus b cube, which is a minus b multiplied by a squared plus ab plus b squared. Now we will write 1 plus tan square theta together. Because we know that 1 plus tan square theta is sec square theta. Now we will divide these two terms separately by tan theta. So tan theta divided by tan theta will be 1 and sec square theta divided by tan theta. Now in place of tan theta we will write sin theta divided by cos theta. This sin theta divided by cos theta becomes sin theta multiplied by sec theta, because 1 divided by cos theta is sec theta. This sec theta gets cancelled with 1 sec theta of this sec square theta. So it becomes sec theta divided by sin theta. This becomes sec theta multiplied by cosec theta, because 1 divided by sin theta is cosec theta and plus 1, which is this one. Now this is the right hand side, so we have left hand side equals right hand side. Hence tan theta divided by 1 minus cos theta plus cot theta divided by 1 minus tan theta equals sec theta into cos sec theta plus 1 is proved. Prove that 1 plus sec theta divided by sec theta equals sin square theta divided by 1 minus cos theta. We will write the left hand side first, and we will write sec theta as 1 divided by cos theta. In the numerator, 1 multiplied by cos theta will be cos theta plus 1 divided by cos theta. 1 divided by cos theta becomes multiplied by cos theta. This cos theta gets cancelled with this cos theta, and we get cos theta plus 1. We write cos theta plus 1 as 1 plus cos theta and multiply this by 1 minus cos theta divided by 1 minus cos theta. 1 plus cos theta multiplied by 1 minus cos theta will be 1 minus cos square theta. 1 minus cos square theta is sin square theta divided by 1 minus cos theta. Now this is the RHS. So we have left hand side equals right hand side. Hence the statement 1 plus sec theta divided by sec theta equals sin square theta divided by 1 minus cos theta is proved. Prove that cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equals cosec A plus cot A. We will write the left hand side. In the left hand side we do not find cosec and cot, so we will divide the numerator and denominator by sin A. So we get cos A divided by sin A cot A, sin A divided by sin A 1 divided by sin A cosec A, cos A divided by sin A cot A, sin A divided by sin A 1 divided by sin A cosec A. Now we will write cot and cosec together. For this one we will substitute cosec square A minus cot square A, because we have the identity cosec square A equals 1 plus cot square A. Now cosec square A minus cot square A can be factorized as cosec A plus cot A multiplied by cosec A minus cot A. We will rewrite cot A plus cosec A as cosec A plus cot A. Now here in this term there is cosec A plus cot A, and in this whole term there is cosec A plus cot A. So we will take cosec A plus cot A common from these two terms and write cosec A plus cot A, which is the common term. Now we will divide cosec A plus cot A divided by cosec A plus cot A. That gives us 1. Now we will divide this whole term by cosec A plus cot A. So this cosec A plus cot A cancels with cosec A plus cot A, and we are left with cosec A minus cot A, which we write over here. At the same time, we will rewrite these three terms as 1 minus cosec A plus cot A. 1 minus cosec A plus cot A in the numerator and 1 minus cosec A plus cot A in the denominator. These two brackets get cancelled and what we get is cosec A plus cot A, which is our right hand side. So we have left hand side equals right hand side. Prove that under root 1 plus sin alpha divided by 1 minus sin alpha equals sec alpha plus tan alpha. We will write the left hand side. In the left hand side, we have to get rid of this radical sign in order to prove this statement. For that, we have to create perfect squared terms inside this radical. So therefore, we will multiply this term by 1 plus sin alpha divided by 1 plus sin alpha, which is the conjugate term of 1 minus sin alpha. Now we will multiply numerator and denominator separately. Multiplication in the numerator gives us 1 plus sin alpha whole squared, and 1 minus sin alpha multiplied by 1 plus sin alpha gives us 1 minus sin squared alpha. Now 1 minus sin squared alpha is cos squared alpha. Here we have got perfect squared terms in the numerator and in the denominator. So now we can get rid of this radical sign and write in the next step square root of 1 plus sin alpha whole squared will be 1 plus sin alpha, and square root of cos square alpha will be cos alpha. Now there are two terms in the numerator, so we will divide separately. So we write 1 divided by cos alpha plus sin alpha divided by cos alpha. Now 1 divided by cos alpha is sec alpha, and sin alpha divided by cos alpha is tan alpha. So this is our right hand side. Hence our statement is proved. Prove that sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta equals tan theta. We will write the left hand side first. Here there are cubic terms sin cube theta and cos cube theta, and there is sin theta and cos theta also. So first we will take sin theta common from the numerator and cos theta from the denominator. So sin theta divided by sin theta is 1. 2 sin cube theta divided by sin theta is 2 sin square theta. 2 cos cube theta divided by cos theta is 2 cos square theta, and cos theta divided by cos theta is minus 1. Next we will write sin square theta as 1 minus cos square theta in the next step. We will simplify this bracket. So this will be minus 2 multiplied by 1 minus 2. Minus 2 multiplied by minus cos square theta will be plus 2 cos square theta. In the next step, 1 minus 2 will be minus 1. This minus 1. Now 2 cos square theta minus 1 gets cancelled with 2 cos square theta minus 1, and we are left with sin theta divided by cos theta, which is tan theta, and this is our right hand side. So we have proved this statement. So this is about trigonometric identities, how they are formed, their use, etc. Hope you liked this video. If you did, please click the like button. Don't forget to press the subscribe button to get more videos on mathematics. Thanks for watching. Have a nice day.